Today, we're going to start our trigonometric adventure by looking at angles, degrees, and triangles. Let's start with the first one. An angle is formed at the intersection of two lines or rays. So when two lines cross, we end up with an angle. We will indicate the angle that we're talking about by putting a little curved line, a little piece of a circle in the angle that we're talking about. That's how we're going to indicate an angle. Sometimes for angles, we'll want to give them names. And I might write the name of the angle at the pointy part. In this case, I'm using alpha. So we're going to use lowercase Greek letters for angle names. We might also use capital letters for angle names. So in some instances, we will use capital letters for angle names. The reason that we want to come up with a different set of letters for these angles is that we're also going to have some lengths. And so we're going to use lowercase letters to represent lengths. And then we'll use capital letters to represent the angles. So we can talk about angle A or side A. This is an alpha, a lowercase alpha. Other lowercase Greek letters that we should recognize are beta, and gamma, one of our most common is theta. These are some common lowercase Greek letters and the way that I personally write them. A triangle is an object that is made up of three angles. Clever name we came up for this with this, right? Triangle, three angles. And yet, whenever we talk about triangles, we always say it's an object with three sides. And so why don't we call it a triside? But then I just ended up annoying my geometry teacher with that one, so I let it go. A triangle has three angles and three sides. The reason that I bring this up is that I want to come up with our usual naming convention if we have to name all the parts of a triangle. Let's just draw a generic triangle. I'm going to say this is angle alpha. Now, if we stand in alpha, alpha is made up of two sides. And then when we're standing in alpha with our hands on each one of the sides that make up alpha, we are looking at another side. We're going to call that the side opposite alpha. And we're going to want to pair A with alpha. Doesn't always have to be the one in the lower left side. But if I have an angle alpha and a side A, and I've named those things, side A will be opposite angle alpha. Angle alpha is opposite side A. If you stand with both hands on side A and you're facing inside the triangle, the angle that you can see looking straight ahead, that's alpha. One of the angles will be theta. So side B is opposite angle theta. Angle beta is opposite side B. And then we'll call the third angle gamma. I'm going to write the gamma inside the triangle next to the little curvy thing to indicate the angle that I'm talking about. Because that's the other place we could label an angle. If there's not enough space on the outside, like here, put it at the pointy parts. I'll put the angle name on the inside. Opposite angle gamma will be side C. This is the usual naming convention for a triangle. That will be our usual triangle. A is opposite alpha, B is opposite beta, C is opposite gamma. That way, if we want a problem, I can just say gamma is so-and-so, C is this, and alpha is whatever it is. And you'll know what parts match up. The other thing that we might do is use capital letters to indicate the angles. But the capital letter should be opposite its lowercase. If someone sets up that side little a is opposite angle capital B, somebody is messing with you, and you probably shouldn't deal with them at all. So I might say, here's side A, or angle A, and that will be opposite side A. Here's angle B, opposite side B. And here's angle C, opposite side C. This is the other usual. Sometimes we'll break from this, but not messing with the A and the A, the B and the B, and the C and the C. We might not need all the names for particular situations. So if only one of the angles matters, and we might call it theta and be done. But this is the usual way we're going to do it. When we're using capital letters, instead of naming the side A, we might name the sides using the angle names, as we're referring to the angles as vertices. So we might say side A or side BC, in which case we have to put a little line over it. Right. Us mathematicians on a friggin' notation, am I right? So side B can also be side AC. And this could be side C or AB. Sometimes we don't care about all the parts, but if we do care about all the parts, this is how we're going to do it. Of course not. You just like the naming of parts. We're coming up on a break. Everybody just hang in there. Everybody okay? Oh, no. I'm far from okay. It's Thursday afternoon. It's 2 o'clock. It's time for a nap. And yet here we are in trigonometry class. This is some kind of torture that someone come up. Why our class is happening. When we're all a little bit fried, we've been sitting here for like an hour. Pick something that everybody knows already. You can kind of like half tune out. Oh, yes. That's nice and comforting because I already know that. But they're like, oh, what is 3 plus 4? You're like, oh, it's like 9, right? Arithmetic isn't my strong suit. So you gotta watch out. We measure angles with things called degrees. If I make a full circle, how many degrees is that? See, you like already know this stuff. If I go all the way around, that is 360 degrees. If I go halfway around, how many degrees is that? 180. If I make a sharp corner like this, how many degrees is that? Look how much stuff you already know. Oh, instead of making a curvy one, what do I do when it's like a 90-degree angle? I put a little square there to emphasize that this is a 90-degree angle. What's another word for 90-degree angle? A right angle. Shit, are you sure you all need this class? Because you like know everything so far. The snarky answer is, I don't know if we need this class. But the list of classes we have to take says we need. Everything else, this is all just fractions of the 360. An angle is just some amount of going around 360 degrees. Going all the way around is 360 degrees. Halfway around is half of 360, or 180. A quarter of the way around is 90 degrees. A quarter of 360. So it like makes sense. When we go around in a circle, that's just the scale. Goes from 0 to 360. And then it's just another 360 if we keep going around. We can have angle measures greater than 360. If we have an angle of 450 degrees that goes around one whole time, and then another 90 degrees, right? 360 and 90 and 450. Successful arithmetic. Is everyone okay? Now we're going to be studying lots of things where angles fall in different pieces of different fractions of 360. But it's 360, that's one full circle. This is a great one full circle. For those of you thinking, should we have used 100? 100 is a terrible number. And it's got the zeros in it, but it's not divisible by anything. It's not divisible by enough stuff. I mean, look at 360. Look at just the 36 part of it. Divisible by 2, 3, 4, not 5. But 6, not 7, 8, but 9, divisible by so many things. It's awesome. 10 sucks. 10 is a terrible base to use. It's divisible by 2 and 5. That's terrible. You make a 10 pack of something, it's like 2 rows of 5 or 5 rows of 2. Oh, shoot, that's the same thing. Look what you get if you use 12. 12 is so much better. 12 is the base we should have used. 12, so much better. Divisible by 2, 2 rows of 6, 3 rows of 4. Ugh, much better. 10 sucks. We still use 12. Because, I mean, every time we're like, when we're counting and we're learning the base 12 system, we could have just been like, look at the clock. There's your 12. Back in the day, when the French went crazy for 10. But we're going to 10 all the things. We're trying to make clocks that are 10 hours long. And they're like, oh, no, you've gone too far, France. We want our 12s. In case you're wondering who to blame, pretty much the English. They don't even use their numbers. It's like 12 inches. Sounds terrible. Why not 10? You have 10 fingers. Because the French are doing that. Oh. Well, it is. Then they infected us with it, and we won't get rid of it. Anyway, what are we talking about? Incidentally, switching to metric system wouldn't really make that much difference. People are like, oh, Americans, they don't understand their own numerical system. I've seen other people from other countries, and they can't deal with the 10 thing anyway. So we're not exactly unique in that zone. All right. Let's take 5 and come back and talk about where we're going from here. I'm going to pause the video and let's take 5.